Today, we're going to start 6.8. Okay? Tomorrow, we'll continue with 6.8. Friday is going to be a formative, so a formative assessment last Friday. Okay? Monday of next week is review. Wednesday, week from today, because I love you all so much, and it's the day of love a week from today, we're going to have a test. Okay? All right? Give me that look. You should be. I mean, what don't you love more than taking the test in that? I mean, there's very few things. I do. Even though apparently the answer key is last year's answer key, still posted on the lines, Roth is going to try and fix it right now. So I give him 7 minutes before he's in here asking me, okay, did I do it right?
Thank you.
Okay, that's all right. Like all of a sudden you screwed up, and I'm like, I like the sweatshirt. I kind of want that sweatshirt. Not gonna mind it. So 2 warm-ups today. 1, find the inverse. That's from Monday, and 1, multiply the 2 matrices. That's from last week, Thursday. Okay. So.
Oh, there you go.
It's hidden today. All right, so the first one is a find the inverse, type 1. So the first thing that I got to do is I got to find the determinant of this one. So DET of this one is going to be 10 times -3 minus 5 times -8. That's going to be -30 minus -40. -30 minus -40 is +10. Would you agree with that? Okay. So then my determinant, not my determinant, pardon me. My inverse is going to be 1/10. And I can leave that, out in front of that one. I switch on my Chris's, so on my main diagonal, I switch them. I negate on my crosses, so that's going to be -5, and oops, I almost put +8 there, but it can just be 8. You got the matrix part right, just forgot the one over the determinant part. Because that's what I thought I saw, but I didn't. Yep. Okay. All right. Then we've got to multiply those 2 matrices. 10 first. 10 I multiply them. Yep. 2 by 2. 10 to 2 by 2 results in a 2 by 2. Okay. So I'm going to make myself, now this is up to you if you make yourself the big old 2 by 2 or not. Okay. First row, first column gives me 8 times 5 minus 2 times -4. First row, second column, 8 times 3 minus 2 times -1. Second row, first column, -6 times 5, 0 times -4. Second row, second column, -6 times 3 plus 0 times -1. Okay? So then that's going to be 40 plus 8. That's going to be 24 plus 2. That's going to be -30 plus 0. That's going to be -18 plus 0. So my resulting 2 by 2 matrix is 48, 26, -30, negative 8. Yeah, buddy? Yeah, buddy. Huh? Questions on that? We're going to use both of those concepts today, which is why we warmed it up with that. Okay? So today what we're going to be doing is, we've already talked about this, today we're going to be learning how to solve systems of equations with matrices. Tomorrow we're going to enhance how it's done, maybe do a word problem or two. Friday is a formative, and your Brown homework is due on Friday. Monday's a review. Next week, Wednesday, the day of love, because we love you so, is okay. All right. So we want to solve this system of equations by hand using matrices. So the first thing that I would recommend you do is you write down this system of equations. Now, for today, behind the screen over here on the left side of the board is the steps. So I'm going to have different steps. I think there's 5 steps to solving by using matrices. Okay? And then on the right side is where I will do all of the work. Okay? So our system of equations is 5x minus 2y equals negative 10. 2x minus 4y equals 12. Okay? So the first thing that I'm going to do is I am going to, even before I convert it into a matrix equation, I'm going to make sure that I have my system of equations lined up. X, y equals number on both of them. X, y equals number in that order. Okay? So then what we're going to do is we're going to convert this into a matrix equation. Now, this matrix equation is going to be 3 matrices. Okay? The first one is going to be 5, negative 2, 2, negative 4. The second one is going to be x and y. And the third one is going to be negative 10 and 12. You tell me how I created a matrix equation out of my system of equations. Yep. How did I come up with the 2 by 2 matrix? Not the lead coefficients, just coefficients, right? Okay? So it's the coefficients, the 2 by 2 matrix is the coefficients written in order, as it is, provided x, y equals number. Okay? Alright? Second matrix, what's my 2 by 1 matrix made up of? The variables, right? Okay? So this one is my coefficients. This one is my variables. And that's going to equal what? My numbers, right? Whatever those are equal to. My numbers. Okay? So that is the matrix equation to go along with this very system of equations. Okay? Step 2 now is I want to say it's like side work. Okay? We're going to, off to the side, find the inverse of the coefficients matrix. Okay? So we're going to find the inverse of this 2 by 2 matrix. Okay? So the first thing that I need to do in order to find the inverse of my coefficients matrix is Inverse. First thing I gotta do. Gotta find the determinant of it. Okay? So the determinant of my coefficients matrix is going to be 5 times negative 4 minus 2 times negative 2. 5 times negative 4 is negative 20. Negative 2 times negative 2 is positive 4. Negative 20 plus 4 is negative 16. So the determinant is negative 16. Okay. So then now the inverse coefficient matrix would be 1 over negative 16. You give me the 2 by 2 matrix left to right, top to bottom of it. Negative 4 and 2 I agree with. Negative 2 and 5 I also agree with. Okay. So that is the inverse of my coefficients matrix. Do we all agree? Okay. Now, this next step, I have simplified it down to. How about here? Let me do this. Let me tap the brakes here for a second. Let me do some mathematics here before we do this to show you what we're doing, what's going on here in this. So I had a coefficients matrix times a variable matrix equals a numbers matrix, right? Okay. So what we can do, remember, in matrix multiplication, the way the order that you multiply a matrix or two matrices in matters. Okay? So I want to get rid of this coefficients matrix, so I am going to multiply here by the inverse of that. Which means on the other side, I have to multiply by the inverse matrix on the same side as I did. Okay? Because I multiplied on the left side here by the inverse matrix, I've got to multiply by the left side here on the numbers matrix. Okay? So with that being said now we're going to multiply our inverse matrix. It's still going to equal now these two right here. These two are they're inverses of each other, so they're going to cancel each other out. That's why we do it this way, because those two cancel each other out. So then that leaves me with my variable matrix, x and y, and that's going to equal, my inverse was 1 over negative 16, negative 4, 2, negative 2, 5, and my numbers matrix was that 12 and 10? Negative 10? Negative 10 and 12. can I multiply those two matrices? Yeah. Dimensions match up? Yeah. 2 by 2 and 2 by 1. So my result is going to be a yes. My result is going to be a yes. What's the size of the result? 2 by 1, right? Okay. So now, what I'm going to tell you is keep that fraction, keep that out in front. Don't worry about that fraction until the end. So this is going to be a 2 by 1 matrix. Okay? I'm going to take the first row, -4 times -10 plus 2 times 12. Then I'm going to take the second row, -2 times -10 plus 5 times 12. So this is 40 plus 24. This is 20 plus 60. 40 plus 24 is 64. 20 plus 60 is 80. Now that it's the very end, now I would say scalar multiply or distribute in that fraction. 64 times 1 over -16. (64) divided by -16. -4. 1 over -16 times 80. -5. Okay. Our last step, then, is we're going to put that resulting matrix into point form, and then we're going to check our work. So what would our resultant point be? If I'm just down to this, what's my resultant point going to be? -4, -5. X, comma, y. If I check it, 5 times -4 minus 2 times -5 is going to be -20 plus 10 is going to be -10, and -10 is equal to -10. 2 times -4 minus 4 times -5 is going to be -8 plus 20, which is going to be +12. +12 is equal to +12. So we get that as our answer. Okay? Now, is it a little bit more work? Maybe, but if you get into like one where you're multiplying both equations by something, it's probably roughly the same. The higher you go, easy. So like if we would solve a 3 by 3 system of equations by matrices, then it makes it so much easier. Okay? If we solve 4x4, it's tons easier. Okay? The more equations you get with the more variables, the more matrices comes into play, but then you got to come up with inverses and all that fun stuff. Okay? Okay? So, what I would like you to do now is I would like you to solve this system of equations using matrices, and you should know at the end if you got it right, because you are going to, you're going to check your work. Yep, you got to check your work to know if you're right. So you should have first converted it into that, then found the inverse matrix. The determinant is -1, so it's 1 over -1. But again, if you want to just write that as -1 out front, that's fine. That one works. Okay? And then when you multiply those two matrices together, you get -3, or -3 and -1. And then you got multiplying by the -1, and so you get 3, 1. And then when you check it, 3 times 3 is 9, minus 4 is 5. That one works out. 3 times 2 is 6, minus 3 is 3. It checks out. 0.3, yep. Okay. Right. You now have enough information. You can do this. You can do the 3 extra problems on the back side if you wanted to get those done. You got a good 15 minutes to get those done.